Chapter 8, we are getting into solving equations. Last chapter, we talked about expressions, okay? What's the difference between expressions and equations? There's one big difference.
You actually solved them.
You actually solve them. What does equations have that expressions doesn't?
Equal sign.
Has an equal sign, okay? So instead of simplifying, just simplifying, we're going to be simplifying and solving at the same time. Okay, so we're actually going to get solutions for our answers this time. Okay, so solutions, we're going to get a variable equal to some number. Okay, what does inverse mean? We've talked about it before. Opposite, right? What is the inverse of addition?
Subtraction.
What's the inverse of multiplication? Good. Okay. Equivalent. What does equivalent mean? Equal, right? Saying equal signs. We're going to be dealing with equal signs. Okay. I did not like any of the examples that the notes had, so I made my own. Okay. So go ahead and copy those two examples down for me, please. Solving equations. What is our main goal when solving equations? To get an answer. Okay. But what is our main goal when solving? Get what by itself?
X.
We want to get the variable by itself. Okay? What is happening between 10 and x right now? Well, operation, right? They're multiplying 10 times x. We want to do the inverse to get x by itself. So what do we need to do? Divide by 10 on both sides. When you divide by 10, what happens on the left?
X comes down.
Right. 10s cancel each other out. X comes down. And then what do we have on the right? 60 divided by 10, 6. How can you check if you got your answer right?
You divide.
Yep, plug that 6 back in. 6 times 10? 60. So you would have done it right. Okay? Looking at the bottom one. What is the relationship between x and 2? They're dividing, so we want to do the inverse, which is multiply. Multiply by 2 on both sides. Okay? What happens on the left?
X out.
Yep. These cancel each other out, so we're left with x. And then what do we have on the right?
12 times 2.
24. Okay? Now, one thing I am going to say, and I'm going to stick to it, is you have to show your work. You have to show your work. You cannot just put x equals 6. It is very important to show your work. Okay? I still make my high schoolers show their work. Okay? Show your work, because when we get to more complicated ones, if you try and do it on your head, don't do that to yourself. Okay? That makes it more confusing. Show your work. If you do not show your work, there will be points taken off. Okay? Show your work. Questions on these two examples? Okay, go ahead and these two examples. Again, I switched the examples to make sure you're looking up here and solving these two problems. Show your work. Looking at number 1, okay, how do we get x by itself? Divide by what? Okay, divide by 17. What is left if I divide by 17 on the left side?
X.
But what about that negative sign? Negative x equals 2. Is x all the way by itself?
No, the negative.
Is x all the way by itself yet?
No.
No. What is still with x? Negative, but it's also a negative 1. So how do we get rid of that negative 1? Divide by negative 1. What could you have done right away at the beginning? Divide by negative 17, right? Right at the beginning, you could have divided by a negative 7. So right away, when you have negatives, you can divide right away by a negative. Okay? On the bottom one, number 2, how do we get x by itself?
Divide. We'll multiply.
Multiply by
3.
3. Multiply by 3, we have x equals 36. Okay? Any questions on those two? All right, let's adding and subtracting. Go ahead and write those two equations down. On these examples, what's happening between the x and the 2 on the top one? They're adding, so we want to do the inverse. Subtract 2 on both sides. What happens when you subtract 2? Right, it goes to 0. So we're just left with x equals 12. Okay, on the bottom one, what's the relationship between x and 6? Subtracting, so we need to add 6. We add 6, we get 0, so we have x equals 16. Okay, I want to do a couple more examples. If I had 9 plus x equals 2, Why do we want to subtract? Because what's the sign with the 9 right now? It's positive. We want to do the opposite, so we want to subtract because remember, we want these to cancel out. If we would have added, we would have had 18. We would have been going backwards. Okay, you want to get those to cancel out. Okay, another example, if I had -7 plus x equals 1. What do I need to do to get x by itself? I need to add 7, yep, on both sides. So you get x equals 8. Okay, so watch out for those negative signs. Okay, go ahead and try these two adding and subtracting examples. On these examples, number 1, how do we get x by itself? Subtract 7, so we have x equals -5. Okay, on number 2, how do we get x by itself? Add 3. So we get x equals -2. Okay? Any questions on these so far? Okay,